Hello, good morning my dear students. Now I am taking one more example on module 4, that is the computation of Karl Pearson's coefficient of correlation. The example, the correlation table below shows that the ages of husband and wife of 53 married couples living together on the census night of 1991. Calculate the coefficient of correlation for the following ages of husband and wife. Here, the data is given in two-way table form, that is, the age of wife over the class interval along the horizontal and that of age of husband along the vertical over the class interval. And here, the number of wives over the class interval 15 to 25 is 1 and that of number of husband over the class interval 15 to 25 is also 1. This is a bivariate frequency distribution, and similarly number of wives over the class interval 25 to 35 is 1 and that of husband over the class interval is also 1. And the number of wives over the class interval 35 to 45 is 1 and that of number of husband over the class interval 25 to 35 is also 1. And number of wives over the class interval 45 to 55 is 1 and that of number of husband over the class interval 45 to 55 is 1. And the number of husbands over the class interval 35 to 45 is 10 and that of over the class interval and the number of husbands over the class interval 45 to 55 is 3 and that of number of wives over the class interval 35 to 45 is 3 and the number of wives over the class interval 45 to 55 is 6 and that of number of husband over the interval class interval 45 to 55 is also 6. Similarly, the data is given over the class intervals as frequency distributions. Then total frequency adding horizontally 1 plus 1 it is 2 and adding 2, 12, 1 that is 15. Similarly it is 15, again it is 10, 8, 3. We call it as total frequency along the vertical, and that frequency along the horizontal, that is adding vertically 1, 2, their sum is 3 and similarly 1, 12, 4 their sum is 17 and then 1, 10, 3 their sum is 14. Similarly 1 plus 6 plus 2 that is 9 and 1 plus 4 plus 1 is 6. Lastly 2 plus 2 is 4. Is the frequency distributed over the class intervals. Sum of all these values is 53. Adding horizontally we call it as their sum is 53 and adding vertically their sum is also 53. Solution: the ages of wives and that of husband is distributed over the class intervals. Here the ages of wives is X series and that of ages of husband is Y series. Here over the interval 15 to 25, 25 to 35, 35 to 45, 45 to 55, 55 to 65 and lastly 65 to 75. We need to compute midpoint of these class intervals. That is the midpoint of the class interval 15 to 25 is 20 or mean of this class interval is 20. Similarly, midpoint of class interval 25 to 35 is 30 or it is midpoint of the class interval is 30. Similarly, midpoint of this class interval is 40, 50, 60, 70 respectively. And similarly, we need to compute midpoint of the class interval, that is the age of husbands over the groups, age of husband distributed over the class interval. Midpoint of the class interval 15-25 is 20. Similarly, midpoint of the class interval 25 to 35 is 30. Similarly, we get 40, 50, 60 and 70 and we call it as Y series. Now, by the step deviation method, here 40 is the central value or assumed mean of the data, and we need to compute by the step deviation method, that is y minus 40. We call it as 20 minus 40 is minus 20, then 30 minus 40 is minus 10, 40 minus 40 is 0, 50 minus 40 is 10, 60 minus 40 is 20, 70 minus 40 is 30. Similarly, for X series, assumed mean of this data is also 40. Then compute by the step deviation method, that is 20 minus 40 is minus 20, 30 minus 40 is minus 10, then 40 minus 40 is 0, then 50 minus 40 is 10, 60 minus 40 is 20, 70 minus 40 is 30. And now dx is defined as by the step deviation method. Here dx is step deviation from the assumed means, right? That is dx is equal to x minus 40 by 10, where 10 is the step length of the class interval, and we call it as x minus 40 by 10, means minus 20 by 10 is minus 2, minus 10 by 10 is minus 1, and 0 by 10 is 0, 10 by 10 is 1, 20 by 10 is 2, 30 by 10 is 3. Similarly, dy is also defined as y minus 40 by 10, that is minus 20 by 10 is minus 2, minus 10 by 10 is minus 1, 0 by 10 is 0, 10 by 10 is 1, 20 by 10 is 2, 30 by 10 is 3. We call it as dy. Now, in the given bivariate distribution, we have frequency of series X over the class interval 15 to 25 is 1, and that of over the class interval 25 to 35 is 1. Its sum is 2, is given in the data. And similarly, frequency of X series over the class intervals 15 to 25 is 2, and that of 25 to 35 is 12, and over the class interval 35 to 45 is 1. Their sum is 15. And similarly, sum of 4, 10 and 1 is also 15, and sum of 3, 6, 1 is 10. That is the frequency of series over various class intervals. And sum of 2, 4 and 2 is 8, and sum of 1 and 2 is 3. And along the vertical, sum of the frequencies 1, 2 is 3, and 1, 12, 4 its sum is 17, then 1, 10, 3 its sum is 14, and then 1, 6, 2 its sum is 9, and 1, 4, 1 its sum is 6. And lastly, sum of 2, that is 2 plus 2 is 4. Sum of all these values of f is 53 along the horizontal and also along the vertical. Their sum is also 53. It should be equal. And now we need to compute f into dy. Here f is 2 and dy is along the vertical, that is minus 2. Their product is minus 4. Here f is 15 and dy is minus 1, that is minus 15. Here f is 15 and dy is 0. Their product is 0. Here f is 10 and dy is 1. Their product is 10. Here f is 8 and dy is 2. Their product is 16. And lastly, f is 3 and dy is 3. Their product is 9. And similarly, we need to compute f dx. Here f is 3, dx is minus 2. Their product is minus 6. Here f is 17, dx is minus 1, that is their product is minus 17. Here f is 14 and dx is 0, it is 0. Here f is 9, dx is 1, their product is 9. F is 6 and dx is 2, their product is 12. And lastly, f is along the horizontal f is 4 and dx is 3, their product is 12. That is the product of f dx. And then compute f dy square and f d square x. That is f dy square is obtained by multiplying dy to f dy. That is f dy is minus 4, again dy is minus 2, their product is 8. F dy is minus 15 and dy is minus 1, their product is plus 15. F dy is 0 and dy is 0, their product is 0. F dy is 10 and dy is 1, this one, that their product is 10. And dy is 16, f dy is 16 and here dy is 2, their product is 32. And f dy is 9 and dy is 3, their product is 27. And f dy is 16, then the product f d square x. Here we have the data for f dx, it is multiplied by dx. That is minus 6 is multiplied by dx, that is minus 2, it becomes 12. And f dx is minus 70 and dx is minus 1, their product is 17. And f dx is 0 and dx is 0, their product is 0. And here f dx is 9, dx is 1, their product is 9. And f dx is 12, dx is 2, their product is 24. And f dx is 12, dx is 3, their product is 24. This is the values of f dx square, and along the vertical the values of f dy square are exhibited. And lastly we need to compute f dx dy and f dx dy. Here f is 1 over the class interval 15 to 25. Then the corresponding values of dx dy means corresponding to the frequency 1, dx is minus 2 and dy is minus 2. Their product minus 2 into minus 2 plus 4 into 1, it is 4, right? And frequency over the class interval 25 to 35, that is f is 1 and dx is minus 2, dy is minus 2 and dx is minus 1, their product is plus 2 into 1, it is plus 2, right? Similarly the frequency is not given, we can leave the data. And now over the class interval 15 to 25 for X series frequency is 2 and dy is minus 1 and dx is minus 2, their product is plus 2 into frequency is 2, it is 4. And dy is minus 1, dx is minus 1, their product is plus 1 into frequency 12, it is 12. And dy is minus 1, dx is 0, frequency is 1, their product is 0. Means rest of the entry is not given. Now here dy is 0 multiplied to dx, the entry becomes, that is f dx dy, it is also 0 0 0. And dy is 1 and dx is 0, that product is 0 into 3 is 0. And dy is 1, dx is 1, their product is 1 into 6, it is 6. And here dy is 1 dx is 2, their product is 2 into 1, it is 2. And similarly, dy is 2, corresponding to this frequency 2, dx is 1, their product is 2 into 2, it is 4. And here again dy is taken as 2 and dx is 2, their product is 4 into frequency 4, their product is 16. And dy is 2, here dx is 3, their product is 6 into 2, it is 12. Then lastly, dy is 3, the corresponding frequency is 1, and dx is 2, dy into dx is 6 into 1, it is 6. And dy is 3, dx is 3, their product is 9, and frequency is 2, their product is 18. And now taking the sum of f dy, that is minus 4 minus 15 plus 10 plus 16 plus 9, it becomes 16. And then sum of f d square y, that is 8 plus 15 plus 0 plus 10 plus 32 plus 27, it becomes 92. And similarly sum of f dx dy, that is 6 plus 16 plus 0 plus 8 plus 32 plus 24, it is 86, right? And similarly sum of f dx, that is minus 6 minus 17 0 plus 9 plus 12 plus 12, its sum is 10. Similarly sum of f d square x is 12 plus 17 plus 0 plus 9 plus 24 plus 24, it becomes 98. And lastly sum of f dx dy, that is 8 plus 14 plus 0 plus 10 plus 24 plus 30 plus 86. And now with the help of the above correlation table, we have the coefficient of correlation for grouped data is defined as R is equal to n into sigma f dx dy minus sigma f dx into sigma f dy, dividing by square root into the bracket n sigma, here denominator is square root of n sigma dx square minus sigma dx its square into n sigma d square y minus sigma dy its square. Using the above data, we get R is equal to numerator is 4398, denominator is square root of 5094 into 4620. We get numerator is 4398, denominator is 4850. After simplification, we get 0.91 approximately is the coefficient of correlation. Thank you.